Hello, everyone. Welcome to today's webinar on communicating your road design. This is the unofficial part 5 to our recent series on reducing the environmental impact of roads through planning and design. I'm Erin. I've been the host through the series, and I have the privilege here of taking us through to our unofficial part 5. So through the last 4 webinars, we have talked at length about things that you can do and can consider to improve your road design and reduce its environmental impact. We spoke at length about how determining the location for your road is one of the most pivotal moments in the life of that road. Now, another pivotal moment in the life of the road is the moment that you communicate your road design through to the builder. A failure to communicate or to communicate your design clearly and effectively can cause many undesirable results and, in particular, an increased environmental impact if it's not built as you expected. So today's webinar is going to focus on different outputs and some tips and tricks that you can do to improve that communication. And of course, a bit of housekeeping before we get started. For those of you here in this live version of the webinar, you are all muted, but please do engage with us at any time using that Q&A section of your GoToWebinar panel. You'll remain anonymous and we will tackle your question at the end. For those of you watching this in the future off of our YouTube page, we do respond to comments, so feel free to type them below. So with that, I will get into it. So let's start by revisiting what geometric road design is. It is a matter of incorporating your topo survey data with your design standards to create a 3D model of a road project. Now, this model and the process of creating this model is one that aims to balance a bunch of conflicting values. We've got costs, maintenance requirements, safety concerns, design speeds, solve those road use considerations, and of course the environmental impacts. Now, if you were to look at one of these in isolation, you'd probably end up with an impractical solution. So we need to evaluate all of those different considerations and conflicting values simultaneously and together through that interactive design process. As shown in this visual here, we've got all the different interactive windows within RoadEng that work together to dynamically update and to provide you visual feedback on how you can manage and balance those conflicting values. As I said, these elements are interconnected. So if you move your horizontal alignment, it's going to affect your earthworks. And we can iteratively design to balance those conflicting values. Now, geometric road design, as I said, it's considering a whole bunch of values, but it allows you to actually compare them and look at them much faster and in more detail, long before crews are on site to actually build the road, which gives you a whole bunch of different benefits. Of course, the opportunity to avoid bad surprises. It can help you better evaluate your options both quantitatively and qualitatively, including an interactive 3D visual of your proposed works. You can improve the safety of your road with design speeds and curve considerations. You can identify and avoid costly and challenging obstacles. Knowing what unavoidable project challenges might be coming up allow you to account for them as they pertains to feasibility or planning or scheduling. As we talked about throughout that entire 4-part series, with design, there's a lot of different things you can do to reduce your environmental impact. We can also improve our operability. Now, all of those benefits of design really are lost if we fail to be able to communicate them and being able to communicate our project expectations. So really, as we get into this, next piece here, communication really is that key moment of design where you are going to translate it into a built road. So it is worth noting, communication exists in all of the different phases of the road's life cycle. You're likely going to communicate with a whole bunch of different stakeholder groups, whether that is clients, different specialists, regulating bodies, etc. And this happens at all the different phases: planning, construction, deactivation. But the most important group and the most important time, however, is that moment that your road is being translated from a 3D geometric design into a built road. So we will be focusing on that key moment and the audience for today's seminar. Now, failure to communicate your design, as I have mentioned, clearly can really lead to confusion. It can lead to project delays, so things going a lot slower than you anticipated. And alongside that becomes cost overruns. Um, and of course, as we've discussed and I re-mentioned today again, obviously those increased environmental impacts. So really focusing on this communication point, that key pivotal moment where we're going from the communication from the designer and planner over to the contractor or builder is the focus for today's webinar. And with that little bit of context to start the webinar, I'm going to pass it over to Matt.
Thanks, Aaron. And turn that on. Perfect. So what Aaron just said makes a lot of sense. So you may have designed the greatest road possible, but if it just stays as a model on your computer, you're likely not maximizing your design's value. So it may help you know where and how you'd like to build the road, but you're likely not the person building it. So without a design being communicated to them, or with a poor design, your equipment operator is effectively doing design for you. So that whole figuring out where to build it and how to build it. And if the equipment operator is effectively doing the design, instead of being able to click in a bunch of different options and weigh the pros and cons of each before selecting the best solution, the operator is likely only considering as far ahead as they can see, and they may not be aware of all other project requirements and environmental considerations. So furthermore, figuring out where and how to build the road is inevitable, and it takes a bit of time regardless of who's doing it. If the designer's doing it, they can do their design well ahead of construction. They can communicate what is planned to everybody involved, and gives an opportunity for feedback, design revisions if needed. But once they land on the best solution, they can communicate that to everyone in the project, and everyone in the project can schedule resources appropriately. So make sure they have the right equipment there at the right time, have it scheduled to have materials on site that they need, so maybe culverts and whatnot, and just kind of that whole idea of looking ahead to help ensure the project goes as smoothly as possible. Now, if the operator is the person doing the design, every time they are unsure of something, they're stopping production. When they're indecisive, they're going slow. And if they discover they need something that they don't have, they have to go and get it. So usually we aren't talking about just slowing down one person or one machine. We're talking about slowing down a crew running multiple pieces of equipment with high hourly costs and burning a lot of diesel. So that whole concept of doing the design really fits well with that old saying that an ounce of prevention is better than a pound of cure. Now, a design can be communicated in several different ways. So you may use tabular data, you may use digital spatial information, and or you may create a document that includes both visual and annotated information to present what you've modeled. Now, from a tabular data standpoint, it may be that you have a data table produced to show excavation volumes expected on the project. So instead of saying, in order to build this road, we have to move a lot of dirt, well, your lot of dirt and my lot of dirt are probably different. So I can say we need to excavate 9,000 cubes of material. We need to use 8,000 cubic meters of material to shape into a road, use that as fill for our prism. And that remaining 1,000 we have to haul back to our spoil site at location X. So giving us those measurable metrics to know how much effort's actually required. In line with that, so materials, dirt, you're probably moving it around on site, not always, but culverts, you're probably not building culverts out of nowhere wherever you're building roads. So with that, maybe you're producing a data table that summarizes the size of culverts you need and gives their location, so you know how many pipes, what size of pipes to order, and you order them well in advance so they're on site when you need them. In line with those metrics, we can pull out the costing information that we have in the software. And then beyond those metrics to figure out effort or quantities to figure out what to order. Um, you can use the tabular data for construction staking. So it's common to use a P line or L line, at least in the forest industry, and creating notes that reference those field markings to say, okay, our L line is X number of meters off of the ribboned center line. At this location, our top of cut is this many meters away, and our toe of fill is this many meters away. So in line with that, we have our spatial data. So the kind of that digital information, whether it's point, vector, or surface information. And that has primarily two uses. So one can be to communicate with other software. So maybe it's that you've designed your road and you want to take the center line over and share it with your GIS department, so they can add it to their database. Or maybe you have your design and you want to share it with your biologists. So maybe exporting it as KML is a nice format so they can see where things are planned in Google Earth. But the spatial data is also useful for construction staking. So locating that road on the ground, so that we could export point, vector, or surface data and take it over to a data logger on a total station or an RTK, or if we're really lucky, maybe share it with our contractor who has GPS machine controls or guidance. And for that, there's different formats we can use for that, but Land XML is a really nice format for that. It'll preserve your actual alignment as an alignment, so rather than a polygon or a polyline, sorry, and will preserve the surfacing and keep your separate surfaces or keep your different surfaces separate. So your gravel surfacing layer or subgrade is going to be separate. And then we have the visual and documentation side of things. So aside from the actual construction aspect, maybe you want that nice 3D rendered model of what you have proposed just as an image, and maybe you take that image out of the software and bring it over into a PowerPoint to use for some community consultation stuff. So those 3D images are nice to speak to with non-technical people, because everyone can kind of get a feel for what's involved there. But if you want that more in-depth approach, you absolutely can. So in our software, we have the multi-plot, and that's where we'll take everything that we've considered while designing. So your plan view, your profile view, cross-sections, data tables, etc. And we can put that on paper. We can organize it appropriately. We can add annotation to help communicate expectations. We can change symbology and line types around, and we can do that very quickly. So we can plot that to paper, or we can take it a step further and we can plot it to an Avenza file. So then the plan portion of that document can be geo-referenced, and you can wander around your proposed project and see exactly where you're supposed to be. And aside from those three top items, equally important is having a design is going to help facilitate discussion. So if you're the designer and you're communicating with the folks that are building it, well, you can say, well, we need to be 2 meters of cut at this location. Our low spot should be up there. Of course, you could do all that just from memory without the actual documentation in front of you, but most of the time, you're not going to look at any of these items in isolation of one another, and you're going to use the actual multi-plot output or something similar when you're in the field communicating with those builders and discussing expectations. And you can look on the ground and say, well, we're here, we should be doing that up ahead, which is right there. We should be doing that, and open up the dialogue. So great for pre-works, great for site visits, supervision, QA, QC, etc. Now, the previous slide, there's a fairly finite number of outputs that we can produce, but there's still a lot of variability for what that actually consists of when it comes time to produce the documentation. So at the most basic level, maybe you're just producing a line on a map, but But then at the other end of the spectrum, maybe your actual design documentation is part of a large document with reports, feasibility studies, geotechnical investigations, um, all kinds of information, gigabytes of digital information to supplement it as well. Now, most of the time, we're going to live in a happy medium between there to do what we'd like to do. So there's issues if we provide too little or too much information. And if we provide too little information, well, the issue is obvious. It's basically the same thing as if we didn't do a design in the first place. Builder has to figure out what's expected and where to build and how to build it. And then from a planning process leading up to that, there's not really enough to know how much effort's required to build what's proposed. Now, on the other end of the spectrum, we have too much information. So one obvious issue is you may, in that example previous with that big stack of binders, you may know all that information as you design, but just putting that to paper takes time. So we'd like to balance the design effort with the benefits that you get from it, and we don't want to just be planning and documenting for the sake of planning to documenting. So if it's not required, why do extra work? And if we're not going to benefit from it, why do extra work? And then from a boots on the ground standpoint, if you hand off massive documents with all kinds of information in them, well, if you're lucky, someone reads that, but it's really hard to parse what's important from all that documentation. So you might water down the important takeaways of your documentation. And then if you're unlucky, they won't even look at it. So it just gets thrown off to the side and they figure it out. So ideally, we'd like our documents to focus on what's important, include everything that's important, and that's going to have a big impact on what we're dealing with, but to remain concise so it doesn't take hours of reading to figure out where some important detail lives in the documentation. Now, there's no one size fits all for this. The best solution for one project may not be the best solution for another project. So there's factors that influence what's appropriate. So at the top there we have survey method and construction equipment. So what I mean by that is if you do this amazing design with LiDAR data and you hit file save as and save a land XML file out of it, that land XML file might be super beneficial for a contractor that has the equipment to use it. So GPS machine controls or actual survey equipment in-house. But if they just have a consumer grade GPS, compass, Clino, and a tight chain, well, that's probably not going to be much good. So maybe you're better off establishing a P line and giving you the tabular staking information to them. Now, the next thing we have on that list is project risk. So with that, project risk can mean a lot of things. It could be that we're dealing with some environmentally sensitive considerations or areas that we can't go or we don't want to negatively impact. And that may dictate that we want to be exactly at a certain location or build it a certain way. Or maybe it's operationally sensitive. So maybe it's we have a high volume road and we want to be really particular about our material specs for surfacing. So we'll be very detailed in what we expect to use there. Or maybe it's just cost sensitivity. So maybe it's if you move the road a little bit in either direction, you're going to have some major cost issues. So we want to pin it down at a certain spot. Then another consideration in line with how much risk you take on is who's building it. So is it going to go to someone that you've worked with that's built most of your roads over the last 20 years? You know, they do good work, and with very little oversight, you can expect them to not do anything that doesn't make sense. Or is it some other local guy that you know is the polar opposite of that, and you're going to have to hold their hand the whole way and spell out what's expected. So first guy, you probably don't need as much detail in what you're communicating, whereas the second guy you do. And then in line with that, well, maybe it's an open tender project where it's likely to go to a lower bid or the lowest bid, in which case you don't know what you're getting yourself into, and you're probably going to want to plan for that lowest common denominator and to hedge your bets too, in case they're trying to say, well, you didn't explicitly detail that this needed to be done, and then they'll come back and try and claw back extras and change work orders, which kind of rolls into that last point under project risk, which is contract structure. So it depends a lot on the project. Size of the project will play a part too. So if you're dealing with large projects, it makes sense to where a lot of little change orders may result in big costs increase. Maybe you try and include more detail so there's less room for interpretation. Now all these factors roll into project tolerances. And in addition to that, if you're dealing with structures, if you're dealing with a bridge, you probably want your bridge to be, or your abutments to be built at exactly the right location rather than plus or minus a meter. So all these things will roll into, well, how much leeway do you give them? Does it have to be plus or minus 30 mils, or does it have to be, as long as they get the gist of what's intended from the design, everyone's happy? So we're going to start focusing on this middle ground. Well, we'll focus on this middle ground, and we're going to start by discussing creating the multi-plot document. And I'm going to cover a bunch of kind of the mechanics of things here to start. But once we get through our little pre-recorded video, we'll step back and talk about some of the key takeaways. So I'm going to click the multi-plot button down here. So I've got my multi-plot open. I'm going to make sure I have it on the page size that I'd like. And then just to help making sure I'm lining up all my neat lines and whatnot, I'm going to add a grid in there. And now I can take this and I can add in my subview. So I'm going to start with my cross sections here. I'm going to size that appropriately. And I've got that exactly where I'd like it. So I'm going to just lock the position. And with that, so if I accidentally nudge that subview, it's not going to move it around. Now I'm going to open that subview options and I'm going to set my scale. And I'm going to set the layout. So in this case, I don't want it to be 2 by 2. I want it to be 4 by 4. And I don't want every one of my report points showing up. So here I only want my cross section shown in 20-meter intervals, and wherever I've said there's going to be a culvert. And we can add a rectangle in there to hold a title page, or our title block, and we can configure that however we'd like. Of course, you can add more than just that. But we'll position that. And instead of just locking the position for this, I'm going to fully lock it. And that is, I'm happy with the title and the position. Now, if I want to edit that, I can just turn on that edit locked item and we can change whatever we want to change. So we've defined our text in that previous one. Maybe we want something that's going to dynamically update. And so if I change the scale in my section view, I don't want to have to remember that I need to change that text down at the bottom right. So I selected that from a drop-down, so that's going to change whenever I change that. Now here, if we look at our sections, I'm going to notice that there is a stationing gap in there. So I'm going to adjust my pagination options. So I've got it going from dot, dot to dot, dot, which is good, but I had it just showing a fixed width for each, or fixed station range for each page. And I changed that to be based off the station. So it's not missing any stations now. And here, actually, I'm just going to so here I've got a little bit of my cross-section not showing up in my design. So I'm going to duplicate that chapter, and I'm going to change the pagination ranges. So my first chapter only goes to 1520, and then my second chapter will go from 1540 to 1565. I'm going to change my layout for that chapter, change my scale, and now I don't have to worry about missing that toe of fill. And then for my third chapter, I'm just going to do the final range. Now here I've got the chapter selected, and I'm adding a little note specific to one cross section. And it's not going to do what I want here. So since I have the chapter selected to the left, over here, I'll position that. And then if I look at the pages inside that chapter, it's appearing on every page. So that's not what I want. If I just want that added to one page, I'm going to select the chapter when I add that text in there. So now we're on page 6, and 7 and 8 are free of that text box. Now I could save the chapter if I wanted to use this in the future. But for this document, I also want to add in a plan over profile. So I've just pulled one in from our Access Web Library, so pre-formatted chapters. And in this case, I don't actually want that. So I've got one saved that I'd like to use as a talking point. So we'll delete that. We'll add in one that's been saved. And it's coming up at the end of my document. Of course, if I want that at the start, I can just shift it up to the top. So using that right-click move up. And so we aren't starting from scratch here. It's largely been formatted, but we're going to make a few changes just for the sake of talking about some things. So if I want to include my slope stakes, we can turn on the checkbox for that. So that's my subview options. So we can see the top of cut, toe of fill as a line. If I want to change some line work, I can come in here and just hit the plus to expand it, and we can change things around to be whatever we'd like. And we can add in new line work that doesn't appear in that default subview options list. So we can go to our template codes, we can hit the plus, and in this case I want to add line work for my inside line for my ditch inside and ditch left and right. And we can change the line work for those independently as well. So one's blue and one's orange in this case. There we are. We can see that ditch line appearing in our drawing. Now, similarly, we'll add shading here next. So we'll turn that on. We'll expand that. So the default's going to be cut and fills. I'm going to start by showing materials here. So we've got those different materials that we're tracking. And we'll add them into our list here. We'll modify to have them show up different colors. And there we are. We've got that hatched. And we can see here, for example, I've got a special material for my armoring at the end of my pipes. So we can see where that's assigned. Now we can have multiple chapters showing the same thing. So I can duplicate that, and I could make this independent. So I could change to show my cut and fill instead. So there we are. We can see with shading where we're in cut, where we're in fill. Now I don't actually want to include that, so I'm going to just hit delete there. Next we have labels. So we'll just turn our labels on, and we've got a few that are turned on here with my previous settings. I've got decimal places showing for my beginning and curve of end curve for stationing, so I don't want to include that, so I'll just set my number of decimals to 0. And we'll reset that formatting for the entire range. So there, we've got rid of that for those labels. And let's change the position. So instead of having a 20 milliliter, we can tabularly change everything at once. So I'll change that back just to a personal preference, if nothing else. Now, if I didn't want to change everything, but just want to change one item, I can go back to my plan view and I can do that there. So the two are linked. So we'll turn this on. Now my scale right now is different than the scale in my multiplot, so I'm going to just set that to be the same, and I'm going to lock my scale so the positioning of those labels is consistent on both. And now I can right-click, add edit label tool, and I can double-click an individual label and change the position if I'd like. So we can see it's taken effect in the multiplot. Now we don't have to just do that tabularly. We can move it around by hand if we'd like. And once again, we can see that that works. And if I'd like to reset everything, I can just turn on that reset all class formatting. Now, we're not just limited to labels that are in the list, so the default labels. We can go on and we can create a user-defined label using the attributes. And the attributes can be the predefined attributes, or you can build your own attributes in location setup. So I'll just add in my station, and we'll hit OK, and I see I've got stationing showing up more frequent than I'd like. So I can go in options and I can say, well, I don't want them every 20 meters, I want them 200 meters, away we go. And if I'd like to, I could change that 200 as well by hitting properties while that's selected. Now here we can click edit. I can add a little bit of text in there. I could add multiple attributes in the same label as well if I'd like. So there we are. Now, another really useful label function is our floating labels. Before I do that, I'm just going to turn on my slope stakes in this view. So floating labels, I'm nowhere near another label. I'm just going to click with add or edit label selected, and I can type in whatever text I'd like. We can configure it the same way as we did previously. We'll leave that as is for now. Make it bigger, but now if I pull this around, it doesn't have a leader attached to where I'd like it to be attached. So if I go down here and change my leader length and set a connector, I'll put a box around the text. We can work with that and we can position it how we'd like. Now with this, and this is a common source of questions. Right now my plan view is oriented cardinal north to the top, whereas my multi-plot is set to scroll, and I have the scroll set at minus 85. So if I set minus 85 there, the two are going to be aligned. And here I just want to flip it to the other side. So there we don't have to rotate things to read it at a reasonable angle. Now with this, we can, of course, position it however we'd like. I'll move that around, get it to where I'm not overlapping with my north arrow there. And in this case, it's kind of hard to read with the contours and the ortho in the background, so I'm going to turn off transparent. Now down here, it's not the same as labeling, but we can add sub-windows. We can add sub-windows which delineate what's been assigned along the range. So if I want to show my ground types, what layers are where, I can add that in. So here I've got hard pan for a good chunk of for my layer 1. And then I can see, I would say around station 920, we switch to gravel. Now if I want those to be at the top above my mass hull, I can just shift them up in that draw order. Now we can do similar things with the cross section. So right now I've got my status field showing. I'm going to turn banding on instead. So banding's a newer feature. So right now I've got band 2 is my horizontal offset for my point codes. Band 1 is elevation. I can add that in so I can get some of that staking information right in the cross section. And if I'd like, I can change it so it doesn't have to show band 1. We can actually add whatever description we'd like in there. And of course, we can turn those off. Now, once we're happy with the document that we've created, we could change the page number if we wanted to put this partway through another document, or we could save the whole workbook. And then once we're happy with it to plot, we'll select the appropriate printer. If I want to print to PDF, I'll select a PDF driver, change my sheet size, and away we go. Or if I want that georeference design, I can hit Save As, and I can change my format to be Avenza right there. So I just covered a fair bit of ground fairly quickly. And I'd be surprised if everyone followed that click for click. But just as a quick summary, some common mistakes that we see, and maybe mistakes isn't the right word, but some things that could make life easier for folks or make it easier to produce a better drawing is to make sure you're considering this stuff. So scale. So plan over profile is a pretty common document format to have as at least one of your chapters. So the actual what is included on each page is going to depend on that scale. So if you want your plan and profile to line up with one another, which is usually what you'd like, you're going to want to have those plan and profile set at the same horizontal scale. For the profile, if you have a design that most of it's climbing up and down at 20%, you're probably going to have a different vertical exaggeration than if you have a design that's largely under 4%. So your vertical exaggeration is going to influence how often that profile is cut to keep it within the allocated window. Cross-section reporting. So oftentimes, or I wouldn't say oftentimes, but sometimes folks will just click the default settings, which may include all their report points. So they're probably getting cross-sections stacked right on top of each other, maybe within a decimal meter of each other. So that's pretty redundant. You end up with really long documents that has extra information that doesn't add a lot of value. So being cognizant of what cross-sections you're including and including important cross-sections. So oftentimes you'll want to include where your culverts are being located. And then if there's something unusual going on that you want to make sure you get a cross-section for a specific station that may fall outside of your auto spacing, you can use the standard editable report points. So you can call out specific locations if needed. As far as labels go, uh, try and avoid overlapping labels. You won't be able to read what's there if things are overlapping. And if you have lots of labels, inevitably you're going to end up having to move things around by hand. Be cognizant of the text size you use. You don't want it too small. You want to be able to read it at whatever page size it's getting printed on. And be cognizant of your line work. So with that, there's a lot of line work that can be really valuable that doesn't always get turned on in folks' designs. Most commonly slope stakes, so being able to see the top of cut, bottom of fill. I find that useful in both the plan and profile view to see, but not every design includes that. And with line work, also be cognizant of what you have for background imagery or hatching as well. So contrast is nice. You want to actually be able to see the design and not have it blend in with something else. Another common issue is designs extending outside of the view extents. So in the plan and profile, maybe usually you'll have auto set, so it's going to cycle through and make sure you get as much road as possible on each page. But if you have something like a switchback, it may cut off the end of your switchback, so you can manually move the view extents around. So using the shift key on your keyboard and the arrows on your keyboard will let you shift, control, and the arrows on your keyboard will let you rotate. So you can position those windows by hand if the auto isn't doing exactly what you'd like. And then same issue is common for cross-section views. And in that video that I just did, I used my pagination, the settings to get around that. So with that, if we want to have fewer tiles on a page so we get a wider extents, we can just section out the pagination settings to include just what you'd like. And of course, you can change the number of tiles on a page and your scale independently then without affecting the rest of your drawing. Now, these next two are somewhat related. Templates with project-specific settings. So we can save our chapters and we can save our workbooks, and we can use those in the future. Now, if you're saving a document to use in the future, a quick recommendation is if you have auto scaling turned off on anything, you usually recommend turning it on. So if you have a design that's 5 kilometers long and you've moved around one of the windows at 2 kilometer and you save that with auto scrolling turned off on that page, you go to another design, it's going to want to look for that exact coordinate. So you're going to have an empty spot in your design. So if you turn auto on, use that as your starting point, and then beyond that, configure things for those project specifics on a project by project basis. And in line with that, these documents can be tedious if you're building them from scratch every time. And it's set up to not have to do that. So it's set up to be able to create templates to use in future projects. So recommend doing it to make everyone's life easier. And they're pretty easy to use once you get them configured. There's not a lot of work most of the time. Then we have background imagery. So watch out for draw order. So if you have an image over top of your topo, you won't be able to see your contours. You want to flip the draw order around for that. Be cognizant of your resolution issues. So if you have a really coarse ortho image and you're looking at it at 1 to 200 for a scale, well, maybe you're not getting a lot of useful information from that image, and maybe it's best to just not include it or find a higher resolution image. Then we have bumping. So I talked about that, locking the position of our windows so we don't accidentally move something around when we're making adjustments, and then our lines are not perfectly lined up. So we want to use the lock functionality in there for the subviews. And then lastly, we have that dynamic text aspects. So if you're adding things like, I don't know, page number or a date, it'd be pretty unfortunate to have to go through and change all those by hand. So if you use that dynamic text or predefined text dropdowns, you can limit the issues associated with that. Now all those kind of mistakes and issues, if we summarize them, we want to standardize where we can. So if there's already standards in your region, that's nice to use those for making the process of producing the document quicker. But it's also nice to read from. So if you're the builder, from the builder's perspective, if you're commonly working in an area and if everyone has the same document layout, you can look through it and know exactly what you're looking at it pretty quickly, just at a glance. Whereas if it's nothing standardized, you have to flip through and maybe read the legend and whatnot more than you would if things were standardized. And we want these to be easy to use, so standards are good. If there's no standards, it's worth adopting some. So it makes your life easier to produce, and it makes everyone that's using the designs easier to see what's going on. Make sure it's legible. So page size, labels, background, etc. All the stuff that we've touched on previously. And wherever you can, make sure you're accounting for the context. So having an appropriate legend, north arrow, grid lines, scale bar, or scale text, and all valuable. And also it's worth noting those sensitive issues with labels, maybe of backgrounds with polygons hatched, imagery, etc. So there's all sorts of tools at your disposal to help make it easy to communicate what you want to communicate. So next we have communicating with tabular data. This one won't be as long. So in this multi-plot, I've got a data table down in the bottom here. So we can add that into our multi-plot, just new subview and add in the data table. Now we don't have to just add those as part of our document. We can open a data table. We can set our point type frequency, similar to what we set in our cross-section view. Here I've told it to show my design totals. I got my station already being reported, so I'm going to go down here and I want to report my subgrade cut, subgrade fill. I want to include my surfacing volumes. So surface volume 10 is that riprap that I had delineated. Include my boron waste, and I'll add in my stripping volume. So really quickly, we've got a breakdown of those quantities. So I can look at the bottom and see what my project totals are. I'm going to make another data table here, and we'll do culverts. So I don't want it just every 200 meters. I want to use my culvert insertion points. Design totals won't add much value here. I'll leave my stations and add in my culvert diameter and culvert length. And there we are. Now, in line with that quantity data, I'm going to just add in my OptiHaul information to my profile. So then we get that OptiHaul graph, which is tracking my material movement, the same calculations the software uses for its design time costing. And I can right click in there and copy it to my clipboard. And I can paste that into another application like Excel, and I can see a really detailed breakdown of everything. If we go down to the bottom here, we'll even see the vehicle or the material movement schedule by a material type. So really detailed breakdown of what's going on there. And then not quantity related, but if I want to get staking information, I can in a tabular form. So here first I'm going to just add in a P line. So I've got this P line, so that's representing my field markings out in the woods in this case. And when I bring that in, we'll see a little black line in my plan view and my cross-section view. So I can see at this location, my field markings are not right on my intended road center line. So I'm about 5 meters off. And of course, our top of cuts and, well, I guess both top of cuts, in this case it's through cut, are going to be important to lay out. So I'll create a new data table that includes that information. Now here I only want at the station points that are marked in the field, so I'll use my P-line survey points. And I'm going to add in the columns. So I want to include my horizontal offset. So that's the difference between my P-line and L-line. And then I'm going to include my P-stake left and P-stake right. So difference from the P-line center line to my stake left and stake right. And we can add a bunch more information in there if we'd like. But that kind of gets the gist of a good starting point. So with that, we're kind of wading into this construction layout. So that table we've just produced, when I'm talking about relating that back to ribboning or stations in the field, if we look at this drawing, well, there's a station at that crest, so that's going to be marked with the station number. So we could say that relative to that station, we need to be 5.6 meters off at center line, and then yeah, go from there. Now, over here we have that georeference documentation. So we've already talked about that, and that is if we take that multiplot and if we hit File, Save as Avenza, I've just zoomed into my plan view here, but we can take that whole document, we can get that little GPS dot that follows us around and tells us where we're at. So we can add a lot of information to the plan view itself. So here I've got my station number labeled, I've got my cut depth at center line, I've got my height of cut left, height of cut right included in their tabularly. So just at a glance, we should be able to get a pretty good idea of what's going on if we're building it. But of course, we could also say I'm at station XYZ, and then we could go look up at the non-georeference portion of the document and say, okay, at this station, our cross-section should look like this. Now, if we go to the right here, we're getting into the more technical, more detail-oriented and the tighter tolerance stuff. So we don't have to just work based off of field markings. We could export that information and we could use it with a total station or RTK. So we could export that as the point data for staking to a point. We could export the line data for staking to a line, or we could export a land XML file to stake to a surface or have the proper alignment in there. And proper alignment meaning curves are curves, not polylines. And then if we go all the way to the right, which is not new technology, but it's certainly more common in heavy civil and municipal side of things than some of the resource sector stuff. But that kind of, with the total station RTK stuff, there's a surveyor there and it'll be, go down a foot, you went too far, add 6 inches of fill and you go back and forth with a staker. Whereas this, the machine controls, there's usually an RTK on the actual machine with a bunch of sensors, so it knows exactly where the machine is and knows where the other parts of the machine are. So as the operator's operating, he can see his bucket position relative to the design surface, see where that is. And so just seeing where that is in real time is your GPS guidance. And then there's also settings where it can be hooked up to the actual machine controls, and it could be, well, automate this excavation if you had a complex cut, or if you're working with a dozer, give the surface and the running with GPS machines on a dozer, the blade will automatically adjust for you to match your design surface. So it's a big time saver. It's not a cheap option for equipment, but yeah, I'm sure there's lots more people in the audience that are more familiar with this stuff than I am, but talk to people that use it frequently and they're talking about the limiting factor with finish grading is they don't want to ruin the machine, not not how fast they can go. So they're doing finish grading in third gear and stuff like that. So producing those outputs for these last two, that digital outputs, we'll cover here next in our communicating with spatial data. So in all these, we'll start by hitting Save As, and we're going to start. It's not really a common construction staking format, but if we want to share that with our GIS folks, maybe we save it as a shapefile. Now when we hit Save as a shapefile, we get options for what we're including. So if I just want my center line, I'll just have my center line turned on and just for the road that I'm working with, so my current road. And we can see it produces the shape and all the associated files with the shape. Now let's hit File, Save As. So DXF is another common file to go back and forth with other software. TWG as well, but it's a good one for staking as well. So here if we're using that for staking, we want the 3D points and polylines. And usually with this, we don't care about all the background stuff. So I don't want a million points for my contour, so I've turned off the background export. Then coordinates, so that's your stake to point stuff. We can set that up and include whatever we want for our fields. Then we can get all the ASCII data for each one of those point codes that makes up our surface. And then down here, I'll go with the land XML. So land XML is really a universal format for going back and forth with other software, other design softwares, and survey equipment and GPS machine controls. Here, if I want to include that actual tin surface for each one of those surfaces, I'll select which surface I'd like. So here I've got my subgrade surface volume 1, 2, 10, and my final merge surface. So it'll save out all those surfaces in the same file, just as a quick glimpse of what that equates to. We can bring it into train here, and I've got my final merge surface selected, so let's go with that. And we can see that 3D model that you'd get if you use that in another software or another model. Or, yeah. So, oops. I didn't mean to do that. With that, we're open for questions.
Great, thank you, Matt. We do have a few questions here that are already in the question pane. I will address those, but just a reminder to our audience, if you have any questions, open that, or you may need to expand your GoToWebinar panel. You can type your question, and we do not share who you are, so that part's kept anonymous. So, Matt, your first question, can you create custom line types?
Yep, I guess I will close that PowerPoint just a sec here. And I won't go through it or make anything overly complex. I'll just show where it's at. So in the location setup, it behaves the same in terrain as well. If we hit this and general, so general tab, symbols, new, you can create your own symbols, and same with line types. You can save those as well. And if you're coming from a CAD environment, you can open a DWG, so take the line type blocks or symbol blocks and read them in. Yeah, so that's where that lives.
So our next question is a comment and one that, yes, we totally agree with. So back on our common multi-plot mistakes, it was just some feedback that we are missing a very important one, which is survey control information. And I don't know, Matt, if you wanted to just talk to that one very briefly.
All right. Yeah, so I don't have anything prepped to show it, but absolutely. So that can be, it'll depend on what you're building with and how you've surveyed it. So if you're going with the kind of the P-line type stuff, well, commonly it'll be have reference trees, and you can include that in there. Let's see here, plan options, radial shots, so they're usually collected as radial shots, and then you can include your symbology for those radial shots, and you can give the offsets for those, distances for those as well. On the more, I guess, traditional survey aspect of things, if you've done like a total station survey or something like that, or even an RTK survey, you can set up those benchmarks and include that in your terrain file. So it's going to be your symbols and line types. You'll set up your benchmark symbols, and you can include labeling for that. So of course, a really valuable thing to know for your benchmarks isn't necessarily roughly, oh, it's in this vicinity. It's going to be the actual coordinates in there. So you can add your labels to include your X, Y, and Z for those, and include whatever number of decimal places you'd like in there as well, to make sure you've got that necessary level of detail to actually build what you've planned to build.
Excellent.
Hopefully that
Okay.
answers what was intended.
Yeah, I think they've got a follow-up here down the list, but we will get to that one in a minute. So our next one, it's a compliment, then a question. They just said, fascinating series, thanks. So thank you for telling us that. We agree. But they are wondering if we could describe the steps that are usually followed when putting a road to bed, which we call deactivation. So I'm not sure if you're able to address output for deactivating a road.
Um, so really, it's kind of one of those things. There's no one size fits all, but the steps can vary, and it can vary widely. It could be just a prescriptive approach where you're not actually doing the design. You're just saying pull back from here to there, uh, delineating by stationing. So the issues with that is you don't really know what you're up against. Most of the time when you're doing that, the road's been there for a long time. You don't know what to expect. So then if you go from a design standpoint, how do you do that? Well, it's very much the same. It's just you're going to, I don't know if I have anything really detailed here. So if it were me, I'd hem in my, I'd use a link feature for my design. So I've got my uh, fill linked with the survey or delineated prism extents, and same with the top. And then I'd move my alignment around here to show that being recontoured. And it can get complicated, or it can stay as simple as you'd like, but then the benefits are you get that actual surface, and you get to know how much actual work that's required. And yeah, so I think from my perspective, and I'm a guy that works at a software company now, so I've got no skin in the game for actually implementing this, but the big benefit there is going to know how much work you're up against, right? You probably don't need to be out there staking it within an inch of what's proposed, but of course, project specifics will dictate what's appropriate.
Yeah, and this is not the first question we've had on road deactivation. So we do, yeah, obviously take feedback from our viewers and users in terms of future webinars. So please stay tuned. Perhaps you will see one of those in our calendar through to the fall. The next question is when using a design to build a contract to be tendered out, where the total end-haul volume and, there is total end-haul volume and rock volumes, etc., found in the design. Is there a quick summary table of these items?
So probably not super quick. That export from the OptiHaul that I referred to, that's going to have all your material movement quantities and categories for whether it's considered end haul or free haul, and it'll include the distance for each. So with that, you could summarize it in Excel, I suppose, but it's not going to give you a total categorical breakdown for this much end haul, this much free haul, etc. Yeah.
Okay. Why don't we say last question, because we are a couple minutes over time, although not as over time as the entire last series. But the next question and last question is how can you rotate symbols such as bridge and culvert symbols for adjacent roads shown in the background of a plan drawing.
All right, let's see here. Just bear with me here while I don't have something for that open, but we should be able to here momentarily.
Excellent. And I will just take this opportunity. I do see some extra questions coming in. We will follow up with you folks directly over email. So yeah, last question. We'll let Matt grab his file.
Okay. So I'm not going to create my surface here, and I'm just going to create something really simple to start. So I've got that symbol selected, rotation. Oh, and would you look at that? Why didn't that work for me? Oh, I know what it was. So I've hit OK there, and I actually want to hit apply here as well. So yeah, we hit OK to set the settings here, but we may have wanted to change if it was part of a polyline. We may have wanted to change that to something else. So we have to hit apply to actually make that take effect. And with this, we can also scale. So that's where that lives. And it works as well in version 10. We have 3D symbols that'll work.
Excellent.
So
Yeah, hey, well, yes, thank you to all the question askers. If we have not fully covered the answers to your questions, please do, yeah, write in that question section. We will address them over email. And to everyone who took the time out of your day to join us for the webinar, thank you very much. Be sure to check out all of our upcoming webinars. They're up on our website. And yeah, we hope to see you at one. Thanks, everybody.
thanks, everyone.